A function capital F is an antiderivative of f on an interval I if f prime of x equals f of x for all x in I. If f is an antiderivative of f on the interval I, then the most general derivative of f on I is capital F of x plus c, where c is the constant. So how do you find the antiderivative? For example, let's take a look at the first function. You have f, let's say f of x equal x to the n, and let's recall how do we take derivative. First we multiply by n and subtract 1 to the exponent. So you multiply by n and then you subtract 1 to the exponent. To take the antiderivative of this, we do the opposite, right? Let's say if you are given f of x equal x to the n, and we want to find capital F of x. Well, then capital F of x, what? So you would do this the step for derivative, but backward. Here, you add 1. So add 1 to exponent, and then you divide by n plus 1. So that now become 1 over n plus 1 multiplied with x to the n plus 1. So you do the opposite, right? And from the last step to the first step. So note that here you subtract 1 to the exponent. So the first step here you add 1 to the exponent. The next one multiply by n. Well, since you add 1 to the exponent, you divide by 1 by n plus 1. Okay. So here we do dividing, that's the opposite of multiplication. Here adding, that's the opposite of subtraction. You will find all other antiderivative by just doing the opposite. The formula for the antiderivative is given here. Let's say you are given f of x equal x to the 3x to the third plus 2 times x to the second plus 1. So the capital F of x. So here we have a 3. The antiderivative of x to the third. So add 1 to the exponent and divide by n plus 1. Add 1 to the exponent, divide by n plus 1. Add 1 to the exponent, divide by n plus 1. And plus a constant c. So this equals 3/4 x to the 4th plus 2/3 x to the 3rd plus x plus c, for c is a constant. Okay. Here we have 4 secant 3x plus tangent of 3x. Recall that derivative of secant of kx is equal to 1 over k times secant of kx times tangent of kx. So our k here in this case is 3. So to do the opposite, given, if you are given 1 over k times secant of kx times tangent of kx, this becomes the function is secant of kx. Now, our k here equal 3. So I can modify f of x to the form that we want. So I have a 4 times 1 over 3 secant of 3x times tangent of 3x. Well, if I divide by 3, I have to multiply by 3 at the same time. So I multiply this by 3. Let's rewrite this a little bit. So now I have 12 times 1/3 of secant of 3x tangent of 3x. So then the antiderivative of this is capital F of x equal 12 secant of 3x plus c, for c is a constant. We can use this to solve the initial value problem. Say we are given dy dx equal 1 over x squared plus 1, and we are told that the initial value y of 2 equal 1. Okay, so let's rewrite this. Dy dx equal x to the negative 2 plus 1. So y equal, so again, plus 1 into the exponent, divide by n plus 1 plus x plus c, whatever the c is. So let's clean this y up. Y equal negative 1 over x plus c. We are given y of 2 equal 1. This implies negative 1 over 2 plus 2 plus c equal 1. So this is 3 over 2 plus c equal 1. Therefore, c equal to negative a half. Then I can come up with the function y equal to negative 1 over x plus x minus a half. Here we are given the third derivative. We want to find what is the function. So we given that y triple prime equals sit. This means y double prime equals sit x plus c. You are told that y double prime of 0 equal negative 8. This implies c equal to negative 8. Which means y double prime is equal to sit x minus 8. Y prime then equal to 3x to the second minus 8x plus c. We told that y prime of 0 equal to 0. This implies c equal to 0. Which means y prime equal to 3x squared minus 8x. Then y is equal to x to the third minus 4x to the second plus c. And we told that y of 0 equal 5. This implies c equal 5. This means our function is y equal x to the third minus 4x squared plus 5. How about we want to do this with the with trigonometric function? So dv dt equal 1/2 secant times tangent t. So let's rewrite this a little bit. dv dt. This meant what? This meant that the derivative of the velocity, that the derivative of this, then v of t, is equal to 1/2 times secant of t plus c. We were told that v of 0 equal 1. This means 1/2 times secant of 0 plus c equal 1. So c equal to 1. C equal to 1/2 in this case. This means c equal to 1/2. Okay, so then the velocity function is equal to 1/2 secant of t plus a half. The next problem, we have a hot air balloon ascending at the rate of 12 feet per second at the height of 80 feet above the ground when the packet is dropped. How long does it take for the packet to reach the ground? Okay. So here, we go ahead and let s of t be the position function for the packet at time t. V of t be the velocity function for the packet at time t, and A of t be the acceleration function for the packet at time t. We are told that the packet is ascending at the rate of negative 12. We know that the packet is ascending, right? The packet is going down purely based on the velocity, based on the gravity of the Earth. When you drop a packet, the gravity pulling onto the packet, that gravity is negative 32 feet per second square. So A of t equal to negative 32 feet per second square. Okay. This then and we were told that the hot air balloon ascending at the rate of 12 feet per second at the height of 80 feet. This telling you that V of 0 is equal to 12 feet per second. I can use A of t to calculate V of t. V of t equal negative 32 t plus c. We were told that V of 0 equal 12. This means c equal 12. So the function V of t is equal to negative 32t plus 12. We are told that s of 0 at the time that it released equal to 80. Okay. Now I have V of t, I can find s of t. Well, s of t now equal to negative 16t squared plus 12t plus c. Well, we're told that s of 0 equal to 80. This means c equal to 80. So then s of t, the position function, equal to negative 12 equal to negative 16t squared plus 12t plus 80. Now the question asks, how long does it take for the packet to reach the ground? Well, we can solve this function. If the packet reaches the ground when s of t is equal to 0, this means negative 16t squared plus 12t plus 80 equal to 0, right? So we can solve that function to find out when the packet hits the ground. We can use the quadratic formula. It's telling us the packet reached the ground when t equal 2.64 seconds. Now, when we take in the derivative, remember the derivative of a constant equal to 0, and when you take the antiderivative, you have to add in the constant. So it really meant that the derivative is really just a family of function of the antiderivative. The collection of all derivatives of f is called the indefinite integral of f with respect to x and is denoted by the integral. The simple integral is an integral sign. The function f is the integrand of the integral, and x is the variable of the integration. So here you are given a family of function, and you want to find you want to find the antiderivative of it. And so let's go ahead and try the first problem. It said the integral of 1/5 minus 2 over x to the third plus 2x dx. This equal to 1/5 x minus, okay, so let's rewrite this a little bit. This is 1/5 minus 2 times x to the negative 3 plus 2x dx. You can apply the rule for antiderivative here. So negative 3 plus 1 make negative 2. Okay, so then divide by negative 2. So 2 divided by negative 2 times x to the negative 2 plus x squared plus a constant, because this is a family of the antiderivative, the family of function. 1/5 x plus 1 over x to the second plus x to the second plus c, for c is a constant. Sometimes we can't really just take the antiderivative right away because we have something that we don't know how. We can try to simplify the function first. So do some work beforehand. So this is the same as saying t times square root of t divided by t squared plus root of t divided by t squared dt. That equal the integral of 1 over t to the 1/2 plus 1 over t to the 3/2 dt. So this is t to the negative 1/2 plus t to the negative 3/2 dt. So again, add 1, divide by it. So 1 divided by negative 1/2 plus 1 make 1/2 t to the 1/2 plus 1, so that is negative 1/2 plus c. So clean this up. This is 2 square root of t minus 2 divide by root of t plus c, for c is a constant. Similarly for part c, let's go ahead and simplify this function first. So cosecant of x is equal 1 over sine of x divided by 1 over sine of x minus sine of x dx. This equal 1 divided by 1 minus sine squared of x dx equal 1 divided by cosine squared of x dx. That is secant squared of x dx. So what is the derivative that gets secant squared? Derivative of tangent of x equal cosecant of. So let's go take a look at our rule. I don't remember. So here's the rule. If we have secant squared, derivative of tangent equal to secant square, right? So here the antiderivative is tangent. So go back here and say, okay, so this equal to tangent of x plus c, that is a constant.